Hello everyone, welcome to a new video. Today we will be starting maths topic of senior secondary and the first chapter is sets. So before that I would like you to subscribe to the channel so that you get notifications on time and give a like and share it with your friends. So we will be uploading maths topic further in the coming videos. Okay, so let's start with the first chapter of sets. So what is a set? Set, it means collection of some well defined objects. That is the meaning of set. Okay, and the term was coined by German mathematician George Cantor. And set is a collection of well defined objects. For a collection to be a set, it is necessary that it should be well defined. What is the meaning of well defined? Well defined means you have to have a purposeful set of things with you. You cannot include anything which is uncountable. Okay, so let's see what you want to know about these sets. To know sets, the basic knowledge you have to have is about the number system, which are the different types of numbers and all. In this chapter, we will be learning about a set and how to represent it in different forms. Okay, different ways how to represent the set. Then comes the different types of set: finite and infinite sets, empty set, singleton set, equivalent sets, equal sets, subsets, and their examples. Okay, then define inside the examples of universal set, complement of a set, and difference between the two sets. So these are all the different types of sets we will be learning in the coming chapter. Then how to do the intersection and union of two sets which are given to you. And also you have to represent the union and intersection of two sets, universal set, complement of a set, difference between two sets using the Venn diagram. All these things will be covered in this chapter, and you have to have the knowledge of number system basic. Now let's see what is a set. Okay, now here we are given with two table on the left side, and on the right side you have got two things. Now let's see what it is written here: the collection of tall students in your school. The word is given tall student, so it is not defined that what is the height of that tallness measured. So it is tall students, not specified properly. Next one is collection of honest persons in your colony. Again, honest persons cannot be understood in any way. What is the rule for the honest person? Okay, collection of interesting books. What is the meaning of interesting book? Some people may have one interest, some people may have another interest. So it is not also a well defined thing. Nothing is defined properly in this one. Interesting books doesn't give you a proper result of anything. You can say price of any book. That is a well defined collection. Next is collection of intelligent students. How do you measure the intelligence of a student? That's also not measurable. Now let's check the things given on the right hand side. Collection of the students of your school whose height is more than 180 centimeters. So it is properly mentioned here. The student who are taller than 180 centimeter. So it's well defined. The same thing here, tall students, and here it is given with a specific number. Okay, so this is well defined. Collection of those people in your colony who have never been found involved in any theft case. Yes, those who doesn't have a case on them. So theft case on them, those people can be identified as honest people in the colony. Next one is collection of mathematics books in your school library is again a well defined set, because in the library you are finding maths book. It's not written interesting books. So this is well defined collection. Next one is a collection of those students in the school who have secured more than 80%. A specific mark is given. You can calculate or get the result based on this rule. Okay, so these things on the right hand side are well defined. So we can call these as a set, whereas on the left hand side it is not a set. It's not well defined. That is what the meaning of a set. Okay, now let's see. Example, toy elephant, packet of sweet magazines. This can be expressed as a collection, and these objects are known as the elements of your set. Okay, they are usually denoted by capital letter, any capital letter, and the elements are denoted by small letters separated by comma and a curly bracket. These are placed inside a curly bracket. This is how a set is represented. Now next to see what are these things. Now some standard notation to represent the sets, like if you see n is set of natural numbers. Natural numbers, what are natural numbers? Starts from 1, 2, starts from 1, then comes 2, 3, like that. Whole number starts from 0, 2, 3, and it goes till infinite. And then the set of integers, positive and negative numbers are known as integers. Set of positive integers, all positive numbers, and set of negative numbers, all negative numbers, -1, -2, -3. This can be 1, 2, 3, and all numbers. Set of rational number, any number which can be expressed in the form of p by q, where q is not equal to 0. Okay, that is what rational number. Any number which cannot be represented in the form of rational number is known as irrational number. Its symbol is I. Next, real number is represented using the symbol R. Real number is combination of rational and irrational number. Combination or union of both rational as well as irrational numbers. And complex number, any number which can be represented in the form of a plus ib. This is complex number representation, where this is a real number and this is an imaginary number, where you have this I. Now we have to learn some symbols, like if you see this symbol, it means belongs to. If you see that symbol and crossed out, does not belong to. If you see this E, it means there exist. If you put a cross across it, it means it does not exist. That these are the symbols used for this set. See here, example, n is the set of natural numbers, and we know that 2 is natural number, but -2 is not a natural number. The natural numbers are starting from 1, then comes 2, 3, 4, like this. So 2 is a natural number, that's true, but -2 is not a natural number, that's true. It can be written in the symbolic form that 2 belongs to natural number. So 2 belongs to natural number, and -2 doesn't belong to natural numbers. Okay, that belongs to the integer collection. Okay, so this is how these symbols are used. Next one is representation of a set. So already we have learned, or we have seen what is a set, and now you have to show how a set will be represented. So we have got two methods here. One is roster method, or you can say tabular form. Next method is set builder form. Okay, so now what is the difference between both of them? Let's see what it is. In this method, a set is represented by listing all its elements separated by commas and enclosing them in curly bracket. So these are the elements in curly bracket, and all the elements in that are separated by commas. Okay, we call this form as roster form. Okay, you can see here these are all in roster form where you use a curly bracket and the elements inside the set. Okay, next form is set builder form. Set builder form means you will be writing in terms of sentences. In this form, elements of the set are not listed, but they are represented by some common property. Let V be the set of vowels of English alphabet, then write V as X, where X is a vowel of English alphabet. So if it is in roster form, you will write A, E, I, O, U, A, E, I, O, U, directly the elements. But if it is set builder form, you have to write the statement that defines it. So X, where X is a vowel, and put a curly bracket around. Now if you see the second example, let A be the set of natural numbers less than 7. So natural number starts from 1, 2, 1, then comes 2, then comes 3, 4, 5 and 6. So these are the numbers. So how you will represent it? X is any element of the set where X belongs to natural number. X comes under the natural number collection, and the second condition is X is less than 7. So both condition you have to write connected using and. This is the way set builder form is written to represent a set. Now you can see the example here, example 1.1. Write the following in set builder form. Already the exam question is given as A is equal to -3, -2, -1. It goes till 3. Put it inside curly bracket. So you write it in set builder form. Set builder form means write as statements. So the first example you can see X, where X belongs to integer. Z stands for integers where positive negative numbers are used, and it starts from -3 and it ends till 3. So your X is somewhere in between +3 and -3. Okay, less than +3 and more than -3. Next one is 3, 6, 9 and 2. So if you see these elements, you will come to know that it is multiple of 3. 3 2s are 6. You can write 3 into 2. Then comes 3 into 3. Then comes 3 into 4. So it is multiple of your 3. Okay. So you can write it as the X element where 3 into any natural number, where n is first time n is 1, second time n is 2, third time n is 3, fourth time n is 4. 1, 2, 3 and 4, which is less than or equal to 4. Okay, and n belongs to this natural number series. So you have to express it in this way. You can use a comma or you can use an and here. Next question is 1.2. Write the following in roster form. So question is given X belongs to natural number and X comes in between 50 and 60. Okay, so since we are starting with this one, our way of writing should be 50 less X is more than or equal to 50. So start from equal to 50, then 51, 52, 53, 54, 55, it goes till 60. 60 is also included since less than equal to is given, and other numbers are also available here. So this is the set of the number. Next one is the set D having the element as belonging to R, that means it is real number, and it shows this condition will be satisfied. Okay, so how to do this one? We have to solve this equation. Okay, to solve that, first one step is to write the equation like this. Now for your understanding, we have to find out what is the value of x using factorization method. So I will just tell you how to solve this question. So if you see here, 6 is the number, and you have to just take care of this symbol what is used here. It is plus. Okay, so the symbol is plus, that means you have to add, and 6 is the number. So just do a prime factorization of this one. 2 3s are 6. Okay, you got this. 2 and 3 are the factors of this 6. Now if you see 2 and 3, can you add it and get a result as minus 5? Is that possible? Yes, that's possible. If you do minus 2 minus 3, the result will be minus 5. Okay, in that case, you can write this statement as x square minus 2x minus 3x plus 6 equal to 0. So I made this minus 5 as minus 2x minus 3x. Okay, now going to the next step. Out of these two, find out what is common. If you see here, it is x square, that means 2x are multiplied here. Here 1x is available. So out of these, you can just take this and this out. That means 1x you will be getting. And what will be remaining here? It is just 1x here minus 2. Okay, now I will see this portion, that is minus 3x plus 6. So from that I am going to take out something that is common. That means minus 3x plus 3 into or 2 into minus 3. Can I write it this way? 2 into minus 3. In that case, cut square minus 5x plus 6 equal to 0. So I'm going to solve this using the factorization method. So factorization method, we have to make sure that what is there, the term without any variable. Okay, that is 6 here. Now if you see, it's a polynomial with the highest degree as x 2, and here if you see 6, if I do prime factorization for 6, it will be 2 into 3. Okay, so 2 and 3 are the two numbers that you have, and if you add the, seeing this symbol, you have to come to a conclusion that you have to add. So how to add and get the result as minus 5? So if I do minus 2 minus 3, I will get the result as minus 5, correct? So now my terms will be written this way. X square, instead of minus 5x, I can write minus 2x minus 3x plus 6 is equal to 0. Now I use these two terms, and then I use these two terms separately. So first two things if I have here is x into x minus 2 into x. Okay, and the other terms are 3 into x minus 3 into minus 2. This is can be the way I can write it. Okay, to make it plus 6 is equal to 0. Now here I take this x and x common outside, take x outside, and x remains here from the first term and minus 2 remains from the second term. Now leave that portion, come to this side, and here again you can see minus 3 can be taken as common, that is minus 3. Now you see nothing is common and put it inside the bracket. So here you have got minus 3 common taken outside. So what is remaining? This plus x. X is remaining here, and in from this term you will have again minus 2 remaining, that is equal to 0. Again we will take this term as first term and this term as second term separated by s subtraction. In that case, x minus 2 is again common. So take x minus 2 common from this, and then what will be remaining here? This x will be remaining, and from here minus 3 will be remaining, which is equal to 0. Now what is the meaning of the first term into second term? Anything a into b is equal to 0. So it means that any one number will be 0 and the output, you can think that this will be 0 or this will be 0. So consider the first term is 0 at this point. So x minus 2 is 0. In that case, you will get x as 2 and the other one is x minus 3 is equal to 0. Take x is equal to 3. So 2 and 3 are the values of this problem. So you will get the subset of 2 and 3 as the result. So the set contains only 2 and 3. These are the two elements. So this is how this question will be solved. Okay, that is done. Now next topic is classification of sets, that is 1.3. So in that we are going to see different types of sets and how to represent them. So first one is finite and infinite set. Okay, finite set has finite number of elements. Infinite, you have infinite number of elements. Okay, what is the meaning of both of them? Now the number of elements in set is not finite. Okay, not finite, while the element p set is finite. What is the meaning? Let's check. X, where x is a natural number. So if you take natural number, it starts from 1, 2, 3 and it continues till infinity. Okay, that is a set of natural numbers. So you don't have a fixed number of elements here. But if you take set B, where x is number of students of your school, so number of students in your school are the limitation, so it is finite. So it has a fixed number of students in your school. So that is the set. So that type of set is known as finite set. The first one is known as infinite set. There you can have the elements counted, that is known as finite. Where you cannot count the element, that is known as infinite set. Hope this is clear to you. Let's go to the next one. Next one is empty set. Empty set means you will not have even a single element in your set. For example, let's check here. Set A, x belongs to real number and x square plus 1 is equal to 0. So let's solve this one. X square is equal to minus 1 in this case, and x is equal to plus or minus square root of minus 1. Is this a possible result? No. You will not have square root of minus 1. Okay, so this is not possible. In that case, this is known as empty set. Now next, let's check. X is number which is greater than 7 and less than 5. So do you have any number which is greater than 7? That means 8, 9, 10 or any number, and less than 5. Less than 5 means 4, 3, 2, 1. Okay, I'm just taking the natural numbers. So is there a combination of this number and this number in this both sets and is given? That means you have to have a result of that. It's not possible. So this again set is an empty set. Such number doesn't exist at all. So the set is told to be an empty set or a null set, and it is represented like this, either using this phi symbol, or you can just put the curly bracket without any element inside that. We call it as null, empty or void set. Okay. Third type is singleton set. The name itself, it is clear. It is single element here in the set. So if you take this example, A is the set, X is an even prime number. So if you start with prime numbers, you will have only 2 as even number, which is also prime. No other numbers are prime other than 2. So it has only one element. So this is a singleton set. Next example is equal and equivalent set. So what is the difference between both of them? Equal sets means both the sets which are given. Here A and B are given. The elements inside are all similar. It can be arranged in a different way, but all the elements are same. You can see here 1, 2 and 3 is available here. The same thing 1, 2 and 3 is available in the second set too. So they are equal sets. There is no difference between both the sets. Other one is equivalent sets. Equivalent set is if they have same number of elements. Here you can see 3 elements are there. Again, if you see here 3 elements are there, but they are not equal. In that case, we call it as equivalent, and this is the representation of equivalent set. Next one is disjoint set. Disjoint sets means it doesn't have a common element. If you see set A and set B here, set A has 1, 3 and 5, B has 2, 4 and 6. No, none of the numbers are common here. So both this set combination, we call it as disjoint sets. Next is an example 1.3. Given that set A has these elements, set B has these elements, are they disjoint? We have to find out. So if you solve this one, you have got 2 and 4 here. If you solve this one, the answer you will be getting is, for B set you will getting -4 and -2. Solve it using the factorization method. You will get -4 and -2. So are they disjoint? A and B, are they same or are they different? They are different and none of the common elements are there. So they are disjoint sets. True, that is a disjoint set. Next one is if A is a vowel of English alphabet and B is pi belongs to natural number and less than 5. So we have to find A and B, are they equal? So in this case they are not equal because one set is of alphabets and one set is of numbers. This is A, E, I, O, U, and this is of numbers less than equal to 5. So this is the set. Okay, and for A it is A, I, O, U, and for B A 1, 2, 3, 4, 5, 6, and you can have to write it as capital letter. In that case, is A and B equal? No, they are not equal. Are they equivalent? Yes, they are equivalent. Which of the following set are finite or infinite? Okay, so A comes as X is a point on a line. So if you take a line doesn't have, this is a line which never ends, and it is an extension. So any point on this line cannot be counted. It's uncountable, and this set is countable because it is less than 50. Next question is, which of the following sets are empty? Empty means you are not supposed to have any element in that. So the first one is X is irrational and X square minus 1 is equal to 0. That means X square is equal to 1 and X is equal to plus or minus 1. So it should be irrational. X is irrational. So it is not irrational, it is integer. In that case, this is an empty set. It doesn't satisfy this and this both at the same time. So this is an empty set. A is an empty set. And then comes X belongs to integer, where X is in the middle of -2 and +2. That means -1, 0, 1 and 2. This is the set. Okay. So it's not empty, it has elements. It has 5 elements. So first one is an empty set. Next example is which of the following sets are singleton? Singleton means only one element should be available in the set. So if you see this, x belongs to integers and then x is equal, this is the condition given, so x is equal to 2. So only one element is available, so this is singleton. Next one is y belongs to real numbers and y square is equal to 2, y is equal to plus or minus root 2. That means minus of root 2 and plus of root 2, positive root 2. These are the two elements. So this is not singleton. This is singleton. A is singleton set. Now next one is check your progress. Exercise number 1.1. Let's check all these things. So first one is which of the following collections are sets. First you have to identify which are sets. So as you know, set is a well-defined collection of objects. So if you take this first one, the collection of days in a week starting with S. Yes, number of days in a week are well defined, and out of that, starting with S, elements are also well defined. You can say Sunday, Saturday are the element in this set. Okay, so this is a set. Collection of natural numbers up to 50. Yes, natural number starts from 1 and it will go till 50. That is also well defined. So this is also a set. Collection of poems written by Tulsidas. So Tulsidas has written some poems. That is also a set. So that is well defined. Collection of fat students of your school. So what does that mean? It doesn't have a proper meaning. So this is not a set, not a well defined element. Inside the following symbol in blank spaces. If A is equal to 1, 2, 3, if set A is having the element 1 and 2 and 3, so 1 belongs to A and 4 doesn't belong to A. Okay, you can write it this way. It doesn't belong to A. Which of the following set the following in roster form? Roster form means you have to write with the elements. So first one is x belongs to integer, and in this set you will have elements starting with -5, -4, -3, -2, -1 and 0. This is the set. Next one is these two conditions. So the elements here are B has the elements 1 and -1. Next one is C is letter in the word banana. So B-A-N. C is equal to B-A-N. D is a prime number and exact divisor of 60. That's not possible. So that is an empty set. Nothing is there, empty set. Next question is, write the following sets in set builder form. So 2, 4, 6, 8, 10. So the first one is multiples of 2. Okay, so you can write it as x is 2 into n, where n starts with 1 or less than, you can say 5. 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 5. So this is the numbers. So you can say n less than equal to 5. Okay, now b is equal to 3, 6, 9, it goes till this. So 3n are the values where n belongs to natural number. So it starts with 3 where n belong to this natural number category. Now see, these are the values given. So these are prime numbers 2, 3, 5, 7. Prime number less than 7. So these are the two conditions. Okay, write it in set builder form. Try it out yourself and write it down. Next one is D is equal to minus 2 and minus square root 2 and plus square root 2. So it can be solution of x square is equal to 2 or x square minus 2 is equal to 0. Okay, so this is one condition for this D set. Are A and B disjoint sets? A and B disjoint sets. No, because you can see 6 is repeated in both the sets. They are not disjoint. Next one is, which of the following sets are finite and which are infinite? Finite means limited number of elements and infinite means not countable. So set of lines which are parallel to a given line. So if you see this is a line, so many lines can be parallel to these lines. Okay, so this is infinite, or you can say infinite I. Second one is set of animals on the earth. That is finite. You can have different animals on the earth which have a count, or their breed has a count. Set of natural numbers less than or equal to 50. This is finite, and this is less than or equal to 5 is finite. Set of points on a circle. Set of points on a circle is again finite because the circle starts and ends. So you have the numbers, the points countable. But a line never ends. That's why it is known as infinite set. Next one is, which of the following are null set or singleton? So if you see this one, the first one is a null set since x square is equal to minus 2 and x is equal to minus 2 square root, which is not possible. It's not possible to find out a square root of a negative number. So it is null set. Next one is x solution of x is equal to, it has only one element, x is equal to 3. So it is singleton. Next one is x square is equal to 2. Okay, which implies x equal to plus or minus 2. So this is none of them. Not even a single option is matching, not null and not singleton. X is student of your school studying in both 11th and 12th. That is also not possible. That is a null set or not possible set, empty set. Next option is find out which is equal and equivalent. This is equivalent and this is equal. So x, the element A is written here, and this is even prime number, that is 2. 2 is an even prime number. They are equivalent. A is equivalent to B. Next one is 1, 2, 3, 4 and a letter of the word Goa. They are also 1, 2, 3, 4, 4 letters. 4 word letters are there. So 4 elements in both. So they are also equivalent. A equivalent to B. Third one, solution of this one, that is 2 and 3 were the solution. We have already found out the answer in the previous question, and then both matches, so both are equal. A is equal to B in this case. This exercise 1.1 is also done. Thank you for watching, and I would like you to subscribe to the channel, give a thumbs up and share it with your friends too. Thank you. Comment if you have doubts in the comment section.